In this video, we're going to estimate the cost of the roof. We're going to do only this small portion where we've been working before that has the roof trusses, and it's on top of the men's locker room. We'll start by looking at the cost reference and see what do we need in order to estimate the roof. We can see that there is a file here. It's called roof assembly cost data. This is a convenient source of data because it has all the items that we need to estimate that cost per square feet. So we see that we can have either a flat or a pitch roof, and the cost is going to be based on the square footage of the roof. Now let's go ahead and create a condition. We'll create a new condition, area condition. We're going to call this roof 1, just because we may have different types of roofs. So I'm going to call it roof 1 for now, and we will later use come back and use some other advanced features. So I'm going to start with the corner and end on the other corner just to estimate this section, and we see that we have 200 and some square feet only for this section. Let's suppose that we want to calculate the cost of a triangular shaped roof, and we will say that the cost of this roof is going to be equals to the area times the cost per square feet. So we need to find out the area, and the area is going to be the length of the roof multiplied by the width of this roof, right? So we have the length times the width and times 2, because we're going to have that same area on both sides of this triangle. Now, when we look at the on-screen takeoff, we don't read directly the value of W. What we read is the value of X, which is the horizontal projection of W. Now, in order to calculate W, we need to do some math. If Y is the height of the roof, then we can say that W is equal to the square root of x squared plus y squared. If we look at the notes, we see that the architect has made a note for the slope of the roof. So the slope is going to give us what is the rise over the run. If we look at the north section of the project, we see that the rise is 3 3/4 for every 12 inch. So in that, with that note, we can calculate the value of alpha that we needed before, and since we can measure the value of x, we could calculate the value of w, which is the width of that roof. So basically we know that the tangent of alpha is going to be rise over run, so that's 3.75 divided by 12. And we also know that x is going to be equal to w times the cosine of alpha. So if we have the tangent of alpha, we can find the cosine of alpha, and then we can find the value of w as basically x divided by the cosine of alpha. Now let's see how we can use the slope to get on-screen takeoff to give us the real area of the roof and not the horizontal projection. First, we need to find what is the slope for this roof. So we'll go to the elevations, drawing 13, and we will be looking here for the north elevation. So we can see that there is a note here that goes 3 3/4 inch for every 12 inch that we move horizontal. For every 12 inch that we move horizontal, the roof will rise 3 3/4 of an inch. So in our previous estimate with the on-screen takeoff, what we were looking at is this horizontal projection of the roof. So what we really need to get is include the slope to find the actual area and not just the horizontal projection. So let's go back to our drawing, the foundation drawing S3, and now in the condition roof 1, I am going to enter the value of the slope. So I would enter here 3.75 for every 12. Now notice that the horizontal projection is 284, and when I click apply and OK, now the area has gone from 284 to 297. So now it's showing the actual area of that roof considering the slope and not only the horizontal projection. We can now use this information to estimate the cost of our roof. Similar to what we have done before, we're going to open our Excel file, and now we're going to create a copy of the RSM table at the end of the workbook, and we're going to rename that RSM table to division 6 wood, and now we're going to also enter the on-screen takeoff data and in the OST tab. So we'll go to the takeoff tab in on-screen takeoff, select the line for our roof 1, copy that, and then paste that values in Excel. So now we have the area in square feet, and we have a division 6 woods that we can use to estimate the cost of this roof. Now, to determine the cost, we can go to the cost data in our course site lists, and we will find there is a document for roof construction. Here we have the construction of the rafters. These are 2x4, 2x6, 2x8, and then separated at these different distances. In our case, we have the trusses. If we look at the drawing here, we can go to the cross section F515, F516. That's this detail over here, F516, and then we see that the trusses are separated at 24 inches on center. So we could use the 24 inch on center, and this would be probably a 2x6. So the cost that I am going to use for this roof is going to be B1020102. So I'm going to just scroll this down a little bit and use here code B1020102, and then I'll use the 2x10, 24 inches on center. I think I'm going to use this one. This looks reasonable. Now again, I am not too concerned with the exact numbers and the values that you're using, because in real life you are going to have information from your suppliers. So in this case, we're just using the cost information that we have in the handouts. So I'm going to use 2x10s, 24 inch on center, and then I'm going to have here a cost of materials that is 0.85, labor cost of 133, and then that gives me a total cost of 218. So I'm using this line number over here. Then for the quantity, The quantity of work is going to be what I took from on-screen takeoff. So I'll go to my OST tab, select the area and square feet, and then I have the cost of this section of the roof. You can continue taking off the rest of the roof. The only difference for the other trusses is the length of the actual truss. So given these cost data, that would be the way to estimate it. There are other cost sources where the variables are the length of the truss and then the area of the roof that we're estimating.